All right, so they give you this situation. Now, there's context of the problem. They talk about how, what is it, trees in a forest, trees apart, okay? And they want you to determine how tall this tree is here, okay? But they walk you through it, okay? So they want you to find H, but there's multiple steps. Now, the reason I like Math Excel is, one, that it does that. It kind of holds your hand and pulls you through the question and the steps that you have to follow. The reason I don't like Math Excel is because sometimes it holds your hands and it pulls you through the question and tells you the steps you got to follow. And the reason I don't like that, you think about what I just said, it was the same thing. The reason why I like it, the reason I don't like it. The reason that I don't like it is because when you're presented with a problem, just in general, using mathematics, that problem usually doesn't tell you how you need to fix it, does it? If it told you how to fix itself, it wouldn't be a problem, right? The ACT, okay, placement tests, those types of things, we're just generally using this stuff to actually operate within maybe a career or the real world. It's not going to tell me, hey, you got to find A first before you can find H, okay? Initially, maybe the first time doing it, this is nice. But in order to find H, we need to look at this blue triangle, okay? So it makes sense maybe initially to wipe away that black triangle. I'm not looking at this, and maybe I went a little bit too much there. Let's just do that, okay? So now I'm just focused on the blue triangle. The next thing I'm going to do is try to figure out information that I know about that blue triangle. Do you know what that angle right there is, that red angle? Or a way to find it? 150. So it's the supplement of 25, right? So we're taking 180 minus 25 gives me 155. Okay? Which that's nice. Okay? And remember, this is telling me to find A first. I know it's not a right triangle, so if it's not a right triangle and I'm finding lengths, I have one option, and that option is to use this formula. That's what we talked about yesterday. Okay? I know I got to find A. That's my variable. Does that make sense? So then what goes with A is the angle that's opposite, correct? 15? So 15 has to go there. Always, when you write the sine, cosine, tangent of any function, okay, so any one of those words I'm using, what's in the parentheses is always an angle measurement, okay? What's in the denominator in this case is always going to be a distance, okay? That's my variable. So when I have an equation, I can only have one variable, right? So this stuff over here, the capital B and the lowercase b, have to be things that we know. Well, look at your picture. What is the only thing right now, visually, maybe explicitly, that you know? We've already used the 25 to get the 155. We've already used the 15. We've already used A. What's left? 400, right? 400 is the distance that I know that I have to use over here. So the idea of, okay, if I'm going to use 400 as my distance, the angle that is opposite that would have to be this angle up here, correct? How do I know what that angle is? What are all three of these angles going to add up to? 180, okay? Or, what I think is quicker, what kind of angle is that right there? It is a cube, but where is it on the triangle? Outside. What's another word for outside? Exterior. Isn't an exterior angle equal to the sum of the remote interior? So isn't that 25 equal to the other two yellow ones added together? So what's this top one got to be then? It's got to be 10. Okay? So that's why back in, I don't know, chapter 3 maybe, we were learning that kind of stuff, is so that when we get to this point, I can find that 10 much quicker than say, okay, 155 plus 15 is 170, 180 minus 170 is 10. Okay? So now 10 goes right there, correct? Do you have enough now to solve for A? So let's cross multiply. I get A times sine of 10 is equal to 400 times sine of 15. Emma, I was sitting over there earlier today, and I didn't realize how bad you can't see. If you want to move, do you have trouble seeing the board? Okay, if you have trouble, you can. The seat's open here, or you can slide your desk over or whatever. But I was over with somebody earlier today, and I didn't know what was going on. I went over there and I couldn't see anything. It makes sense. So how do I now? If this is sine of 10. Sine of 10 is a number, right? Okay, so it is, what do we call it for A, if it's a number times a variable? Sine of 10 is starts with C, the coefficient. So to separate the coefficient and the variable, I need to divide them. So divide that side, and now I'm going to come to the right-hand side and divide this side. So you get A equals 400 sine of 15 divided by sine of 10, okay? Grabbing our calculator, and this is something that I just want to explain. I won't talk. We had this issue in the last class. Somebody was using a calculator that they didn't understand how. They understood they had all this stuff written down. Okay, they had 400 sine of 15 over sine of 10. They had it all written down, but they don't know how their calculator works. So they're getting the wrong answer. Okay, so when they type it in, that's getting the wrong answer, right? So let's put ourselves on the end of course exam kind of mentality. If I do all the work on the end of course exam, all my scratch work correct, and I grab a calculator that I'm unfamiliar with, and I start typing things in, because they let you bring your own calculator. There's a list of calculators that are approved. If I bring a calculator that I've used for all year, but I don't really know how it works with, like I've used it for multiplication, division, subtraction, addition, but I don't know how I program it and use order of operations to do something like this. I can do all the work correctly, get the wrong answer, type in the wrong answer, and the state of Ohio says you are a poor geometry student, not because you didn't know how to do the geometry, because you didn't know how to use the technology. Does that make sense? And that sucks, okay? So my suggestion to you, if you get this by hand, grab Desmos. It's so much easier, so much more efficient. And I can type it in, and it gives me my answer, or it types it in the way I would have written it. Okay, now I know this answer is wrong because it's talking about a distance, right? And distances can't be negative, right? Anybody know why it's giving me a negative distance? It's in radians. So I need to change that to degrees, and now I've got my distance. And I always want to check that distance. Does that distance kind of make sense in comparison to the 400 that I started with? Like if this number was like 4, and I got an answer of 596, I can probably guarantee myself I've done something wrong. But those are kind of in the same ballpark. Those are close results. So now we have A to be that 596 number. And I'm going to, just to round it, it's terrible rounding, but I'm going to round it right now for this purpose, this problem, to 596. Because we're not done yet, right? So the question says, continue on and find H. So I'm going to do this. I no longer need that blue triangle in order to find H. I don't need that 400 to find H, because we now know that this A was 596, so approximately 596. What kind of triangle is this? It's a right triangle. So what works in right triangles? Sine, cosine, and tangent, right? SOHCAHTOA is your go-to tool for right triangles. And you're saying sine, right, Hunter? So Hunter's saying H is opposite, 596 is hypotenuse. So if I go sine of 25 degrees is equal to opposite over hypotenuse. So now how do I solve for that hypotenuse? How do I get that H by itself? 596 sine of 25 is equal to h. Now the way Math Excel sets you up, what do they do? Tell you to round the first one, round it to approximate the nearest tenth. Okay, so do not round until the final answer, then round to the nearest tenth as needed. So they're kind of walking you through how to round. I want to do this problem as if my end-all question to you was, how do I find h? And I want you to round it to the nearest tenth. Okay? Well, right now, if I go 596, and I round that, and I go sine of 25, it gives me 251.8. But I rounded that number right there quite a bit, correct? Okay? Even if I round it to 596.2, so let's just put a series of these values here, 596.2 sine of 25. Okay? Now we see that the comparison of those two numbers. Okay? Now they both would round, I guess this one would round to 9, right? 0.9. This one would actually round to 2.0. Does that make sense? Because of that 6 right there. So I'm going to round that to a 0, and then we carry the 1. Okay? So that would give me 252.0. This will give me 251.9. Just by that decimal place right there being off a little bit. Okay? Even if I type in 596.1917, okay, I'm still going to be off. The best answer is all of that number, right? And even if I just cut and paste that whole number or type in that whole number, remember we've had a discussion that 5, there are things that happen after that, right? Okay? So with Desmos, you have the capability of just calling this number A. So now, when we go ahead and we find, because A was this, right? Okay, so H over A would be essentially what I'm doing here. Multiply both sides by A. If I take A times sine of 25, that's the best answer. Does that kind of make sense? Where you can see then, how does that compare if I would have gone to that? They both, now if I, so those start differing in the, what's at the thousandths place. Okay? This is exact up to that 2 right there. Does that kind of make sense on how to use your technology to eliminate or at least mitigate, to minimize your rounding error? Okay. I think that's a huge part of understanding mathematics, is knowing when to round. And I'm going to suggest you always round as late as possible. Okay. Now some of your calculators kind of suck. So let's do this. Google calculator. Like this calculator. Okay. Well, that even isn't terrible. Who's got a calculator? Braden, let me see your calculator. So if you've got a calculator, nothing against you with this calculator size. Okay. Based on what other calculators do. Like this one, if you figured out that you got to do things backwards. Okay. So if I want to do exactly what we were stating in this question over here, if I wanted to find that right there, okay, on Braden's calculator, I actually have to hit 15 first, and then I have to hit the sign key, and then I have to hit enter. 15, maybe I don't, on this one I don't have to hit enter. Some of them you have to hit enter after you hit the sign key. So 15 sign, it gives me 0.25. Then I multiply that by 400, hit enter, and we divide that by, then I have to hit 10, and then sign again, and then hit enter, and then it gives me my 596.19. There's a lot of things I got to work backwards and hit enter a lot of different times. Does that make sense? Okay. A lot of places I can make a mistake, and then if I make it like a sine inverse question where you're actually finding the angle measurement, it gets even more complex. Okay, working backwards with that. So many places you can make a mistake and not really be aware of it. Okay. And of course, exam, I would not use that calculator. Okay. Obviously, the end of course exam is going to build in Desmos for you, right? If I were you, I was taking that test. I would start getting comfortable with Desmos a little bit, okay? These are even tricky, okay, because they don't have the math print on them to where you can see it written or typed in like you would have written it. That make sense? Okay, so please, I mean, like if I've got an option to walk to school, drive to school, fly to school, am I going to walk? Probably not going to drive either, right? I want to use the thing that's most efficient, right? Desmos is the most efficient for us, okay? Don't use something that's a tool that's going to hamstring you just because you're being stubborn. And I know there's people that are stubborn. Okay, I'm stubborn. I get my ways, but that's a huge thing. I want to work on this problem real quick. 42. Let's pull it out. 15 here. Let's call that X. And let's make this 13. And I want you guys to take the next 4 or 5 minutes and see what you can come up with, creating the proportion that you need there. And then once you get that, if we got time, continue to work through and come up with what you think X is.